Reciprocal equations. An equation which remains unchanged when the given variable x is replaced by its corresponding reciprocal, and the equation doesn't change, then such equation is called a reciprocal equation. We'll illustrate the procedure for solving reciprocal equation with help of examples. Given example or given equation is x power 4 minus 3x cube plus 4x square minus 3x plus 1 equal to 0. Dividing both sides by x square, dividing both sides by x square, we get x square minus 3x plus 4 minus 3 over x plus 1 over x square equal to 0. Now by combining x square and 1 over x square, we have x square plus 1 over x square. Let's group them together and take minus 3 common from minus 3x and minus 3 over x. So this will give us x plus 1 over x plus 4 equal to 0. And now if we suppose that x plus 1 over x is equal to y, let x plus 1 over x is equal to y. Then taking square, this would be x plus 1 over x whole square is equal to y square. And if we expand on left hand side, this will become x square plus 1 over x square plus 2 times x times 1 over x equal to y square, and x can be cancelled with 1 over x, resulting that x square plus 1 over x square plus 2 is equal to y square, and we can have x square plus 1 over x square is equal to y square minus 2. Now we can substitute the values of x plus 1 over x from equation 1 and from 2 back into the given equation, and this will give us y square minus 2 minus 3y plus 4 equal to 0. Substituting, what we get is y square minus 2y minus 3y plus 4, and this gives us y square minus 3y plus 2 equal to 0. And now this is a quadratic equation which can be solved easily, which is quadratic equation in y. And for solving this, we'll have y square minus 1 plus 2 times y plus 2 equal to 0. And upon simplification, we get y square minus y minus 2y plus 2 equal to 0. This gives us y times y minus 1 minus 2 common, y minus 1 equal to 0. if we take y minus 1 common, that should give us y minus 1 times y minus 2 equal to 0. So either y minus 1 is equal to 0 or y minus 2 is equal to 0. And here we get y is equal to 1, and here we get y is equal to 2. Don't forget that y was equal to x plus 1 over x. So let us replace y by its originally whatever was its value. Replacing y by x plus 1 over x, and this will give us x plus 1 over x equal to 1, and here it will give x plus 1 over x equal to 2. This will result in two more quadratic equations. Now when we multiply x on both sides, this will be x squared plus 1 equal to x, and here it will be x squared plus 1 equal to 2x, which means by standardizing this will be x squared minus x plus 1 equal to 0, and here it will be x squared minus 2x plus 1 equal to 0. The first quadratic equation, if we compare it with the standard quadratic equation, here a is equal to 1, b is equal to minus 1, c is equal to 1, and if we apply quadratic formula, that would give us x equal to minus b plus minus b squared minus 4ac divided by 2a, and on this side this is a perfect square of x minus 1 whole square equal to 0. Therefore value of x will be 1, 1. 1 is a double root of this equation. And for this quadratic equation on the left hand side, let us substitute the values of a, b and c. X is equal to 1 plus minus 1 square minus 1 square is equal to 1 minus 4 minus 4 times 1 times 1, that is still equal to 4, divided by 2. And here we get x equal to 1 plus minus minus 3 square root divided by 2, and we have 1 plus minus under root 3 iota divided by 2. Remember that whenever there is a negative inside square root, that minus could be replaced with iota outside the square root. So these are the two values for x, and we have 1 as a double root. So solution set would be equal to 1, 1, 1 plus under root 3 iota by 2, and 1 minus under root 3 iota divided by 2. This is the solution set for the given reciprocal equation. Let's take a look on the second reciprocal equation as well. I mean the second example. And this example, given equation is x minus 1 over x whole square plus 3 times x plus 1 over x plus 1 over x equal to 0. We have to expand the first term x minus 1 over x, because if we keep x plus 1 over x equal to y, the first term is not going to be y squared, because there is a negative inside. We need positive here. So that's why we will first expand it and then bring the positive sign. So this would be x squared plus 1 over x squared minus 2 times x times 1 over x plus 3 into x plus 1 over x equal to 0. And we can cancel out this x. This would leave us x squared plus 1 over x squared plus 3 times x plus 1 over x equal to 2 will go on the other side. And now we can add 2 on both sides. X squared plus 1 over x squared plus 2 plus 3 times x plus 1 over x equal to 2 plus 2. The reason we are adding 2 on both sides is because this first term, this first group of 3 terms, will become the complete square of x plus 1 over x whole square plus 3 times x plus 1 over x equal to 4. So that is the magic here. Now if we have x plus 1 over x equal to y, now let x plus 1 over x equal to y, and then this first term is y squared. This means y squared plus 3y is equal to 4. And if we bring 4 on the other side, this is a quadratic equation. Y squared plus 3y minus 4 is equal to 0. Here AC is negative, therefore we will find two such factors of 4 whose difference is equal to 3. This means y squared plus 4 minus 1 y minus 4 equal to 0. So we have y squared plus 4y minus y minus 4 equal to 0. And if we take y common, that will give us y plus 4 minus 1 common, y plus 4 equal to 0. And we take y plus 4 common, leaving inside y minus 1 equal to 0. So this gives us either y plus 4 equal to 0 or y minus 1 equal to 0. This means y is equal to minus 4 or y is equal to 1. So either way, we are going to replace the y by its value, replacing y by x plus 1 over x. So this would be x plus 1 over x equal to minus 4, and here it would be x plus 1 over x equal to 1. And now we have two quadratic equations. We can standardize them by multiplying x on both sides. X squared plus 1 equal to minus 4x, and this will be x squared plus 1 equal to x. X squared plus 4x plus 1 equal to 0, and this becomes x squared minus x plus 1 equal to 0. Now we are going to apply quadratic formula on both sides. So this would be x equal to minus b plus minus b squared minus 4ac divided by 2a for both quadratic equations, this x would be equal to minus 4 plus minus 16 minus 4 divided by 2, and here on this side x would be equal to 1 plus minus 1 minus 4 divided by 2, and in this case x is equal to minus 4 plus minus under root 12 over 2, and here we have x equal to 1 plus minus negative 3 square root divided by 2, and x in this case would be equal to minus 4 plus minus 2 times under root 3 divided by 2, and here x is equal to 1 plus minus under root 3 iota over 2, which means whenever there is iota, it means the roots are not real. That iota shows that the roots are complex roots, and here the value of x upon taking 2 common and then cancelling it gives minus 2 plus minus under root 3. So the solution set is equal to minus 2 plus minus under root 3 and minus 1 plus minus under root 3 iota over 2. So this is the solution set for the given reciprocal equation. We can similarly do any other reciprocal equation. Remember that in one term, when we substitute y, the other term must give us y square. That way the reciprocal equation will get converted into quadratic equation. We find values of y and then replace y by its original values, and that way we generate 2 more quadratic equations which upon solution give us the required solution set.